morning. Mr. Lisham is here. Okay, my beard is very short today. Beard is very short. Bless you, Israel.
Someone hit me in the head. Someone hit me with the book.
Pizza? Okay, alright guys. We've got quite an important lesson and a little bit of a confusing one. Okay, but we're going to work. I spent some time on it yesterday and I'm going to go as the book done it. And it's very important that we work in the same process. Okay? Because I think it will simplify for you. So what are trig equations? These are trig equations. And you actually solved these trig equations last year. Okay? Sine theta equal half. Now, if you want to use the calculator, how would you solve that?
Inverse of sine.
Yeah, you'll just say theta is equal sine minus 1, that inverse of sine. It's not sine to the power minus 1, it's that inverse sine, that button. Okay, and you put half there. Okay, now the thing is you don't even need the calculator because it's a special angle. Not exactly? 30. And the answer is 30. Okay, or let's put one, we'll put 30. Okay, but, and I'm going to draw my circle here. We always have to have that circle, right? Okay, let's do that. Okay, so this is theta. We can't get away with that. We always have that, right? 180 plus theta, 360 minus theta. Okay, that's not the only solution. Already last year, okay, we said actually there's two solutions. Okay, what does the theta equal 30 means? It really means that if I put sine 30, I'm going to get what?
Theta.
Half. Okay, that's what this equation means. Okay. If I choose an angle which is 30, I should get a half. Okay? But I should have at least one more answer. At least one more answer. What's the answer? What other angle? What other angle will also give you sine that angle equal half? I'll just pause it. Okay. So we're looking for another angle other than 30 that if we put that sine other angle, we should also get a half. Okay? Now let's just have a look at here for a second. Okay? If I draw that triangle, okay? This is my y, this is my x, this is the r. Okay? Right? What is sine theta? Sine theta is basically the y over the r, right? The opposite over the hypotenuse.
Yes.
Is there another place here, somewhere on this quadrant, on that on that plane, that has the same y? Yeah. Is there another one? On the second quadrant, okay? Yeah. On the second quadrant, these y's are the same. The x's are different. Now this is minus x, but the r is the same. So we have another angle here, okay, which is 150, okay? If I put sine, I'll write it down. If I put sine 150, and you can put it in your calculator now, you're also going to get a half. Yeah. Okay? So we have two angles, 30 and 150. Okay? I'll maybe write them like this here. So the first one is 30, the other one is 150, and I'll write down this is theta. This is really 180 minus theta. Okay? Right? It's in the second quadrant. Yeah? Right? Now the question is that it? Are these all the solutions we have? Yes. Okay? Last year, we already learned that last year, it's a bit of an extension. It's more of a grade 11, but we learned in grade 10. We learned, these are the two solutions. I can try 180 plus 30, 210, but that's not going to be half. That's going to give you minus half, because y is negative. Yeah. I can try 360 minus 30, which is 330, but again, that's going to be negative half. But I'm saying now there is more angles. Yeah.
What do you mean more angles?
There are more angles that if you put sine the angle, you get half. We learned it this year. What can I add to an angle which is not going to change the sine or the cosine or the tan?
360.
360. Right? If I put 390. Try sine 390.
It does work.
Sine 390, you already know from earlier, a couple of lessons ago, that's the same as sine 30. Because all I've done, I start with 30, and I added another 360. So 390. What can we do more?
What's
we can add another 360, right? Nothing stop us adding another 360. 750.
7.
Right? And actually, how about if we add in 360, maybe we can subtract 360.
So take 30 minus.
So it'll be 30 minus 360, which is minus 330. Try sign minus 330.
Yeah.
It's also going to work.
Sure.
And I can do minus 690. Take another 360 then. Okay?
690.
But that's not even all of it. What about these guys? I can do the same thing for that. So what can I add to 150?
570.
I can add another 360, right? Which is 510. Right, if I'm adding 360 to that, from here to here, I'm adding 360. I think I got it right. Yeah, it will be 510. I can add another 360.
870.
What is that?
870.
870. Or I can minus 360. I can minus 360. How much would that be?
Negative 210.
210, negative 210. And on and on and on and on. So actually, when I ask you how many solutions we've got, infinity. There's infinite number of solutions. So what we're trying to do is find the general solution. I can write this table and carry on for 5 days. I'm not gonna be able to write infinite solution. So we learn how to write it in a compact mathematical way. I'll just pause here because I want to make sure I'm using the same symbols. Okay, all right. So when I want to write down what's the solution, I'll rewrite the equation. The equation was sine theta equal half. Okay? I want to find the general solution. The first step I got to do is I recognize the reference angles. And this is where it's important that we use the same symbols, all of us. We're going to say that the reference angle, that's how I'm going to write reference angle, okay? We know we can use the calculator, we can say sine minus 1/2. That's how we find the reference angle, okay? But we hopefully know that this is a special angle, it's 30, okay? So that's the reference angle. The reference angle forever, ever lives in the first quadrant, okay? Now we say like this, right? The general solution, okay? The general solution is going to be theta equal, I'm going to use exactly as they write it, okay? I'm going to take the reference angle and I'm going to say, I'm going to add 360 to it, yeah? But not just one 360, I can add 2 times 360, right? Or 3 times 360, or minus 360, or minus 2 times 360. So I'm going to multiply it by k, and I'm going to say k, what about k? Can k be 1.1?
Yes.
No. K can be 1, it can be 2. Give me a few more things that k can be. 16, 60, 3, minus 5, minus 7. Can it be 0? If k equals 0, well, that's just gone. And we said it can be 30. So what is k? What k can be? What is it called? It's a whole integer. Integer. It can be negative. So we say k belongs to z. Z is the integers. Okay? Integers. Okay? So that is half the solutions. Why half the solution? Because I know I've got another whole bunch of solutions. Let me stand here. Okay? What's the other solution? Not based on 30.
150.
150. Okay? So the other option is that I can check that. I can say, all right, 150. Okay? I can look at the angles in the second quadrant. And again, I can add k times 360. So this is the solution. Okay? That's the solution, the general solution. Put any k that you want, as long as it's an integer, and you'll get an angle that solves that equation. I'll pause here. Okay, so our next example, we chose a cos, you see, because it will be a bit different. And then I deliberately chose a number here, which is not going to give us a special angle. So you've got that, okay? What we're going to write down is, first of all, what's the reference angle equal? Okay, the reference angle will be equal to, how do I find the reference angle? How did I find the reference angle before?
Inverse.
The inverse of cos. 0,3. And Jacques, you already found the answer. What was it?
72.5.
72,5. That's the angle. Just not special angle, just some angle. Okay? Now I already know that really there should be two different angles here. Really. We call it theta 1 and theta 2. Okay? The first one is, okay, 72,5. But there should be another one. There should be another one that lives not in the first quadrant. Which quadrant will be my next angle?
Oh, I think so.
Second quadrant.
The fourth quadrant. Because cos is positive on the first and the fourth. Okay? So here it's positive. Our first reference angle is always going to be in the first quadrant. The second angle is going to be in the fourth quadrant. How do I go from 72.5 to the fourth quadrant? What do I have to do?
360 minus 70.
Correct. So I'm going to do 360. That's why I always have to start any question with this little diagram. Minus 72,5, which is equal to
287.5.
287,5. We're 100% sure about that one?
I doubt it.
Yeah. Okay, I think it's fine. Right. So in grade 10, that would have been our full answer. We got two solutions, sir. Now we know actually we have infinite solution, just like we have infinite solution here. Okay? So what will be our general solution? Okay, let's write it down like this. Theta is equal to what? You guys help me now.
72.5.
72.5 plus K times 360. Okay, where I'm saying that K belongs to Z.
You always have to say that.
Yeah, because otherwise K might be minus 5.3. It's not. Okay, and that's one class of solution we can say. And I just want to, am I using the same? Yep. And then the other case, or what's the other option? We used the 72. What else we didn't use?
360.
Yeah. So not 360. What did we say? What's the other angle? So 72 was 287. 287,5 plus K times 360. Okay? You don't need to write down K belongs to Z again. It's for both of those. Okay? So that's your general solution. Alright? Let's pause again. So far, so good. I think, okay, it's a bit different. We got to remember to add these K360. But things become a bit more difficult when I get a negative number. Okay? Right? So here I had cosine theta equals 0,3. Now I've got cosine theta equal minus 0,3. We actually did do that last year. Okay? And the way to do it is, again, first of all, to find the reference angle. And just like I had here the reference angle will be equal to cosine minus 1. What do I put here now? To find the reference angle is not actually the theta that I'm looking for. It's not the angle I'm looking for. It's an angle. We call it a reference angle. And as I said, the reference angle always lives in which quadrant? The first. Now, cos of an angle in the first quadrant, what will it be? Positive or negative? Positive. It will be positive. But this is negative. So obviously this angle does not live in the first quadrant. That's why I'm not looking for it now. I'm first looking for the reference angle. So I should put negative 0,3. I should put positive 0,3. Okay? 0,3. I must ignore sign. I'll write it down for you and you can add it if you want. To find reference angle, first ignore sign. When I say ignore, I mean get rid of it, put the positive. Are we happy with that? That's not going to be our solution, but we're going to use it now. So I know already what that is. We found it here. That was 72,5. That's our reference angle. Okay? It's not our solution, it's the reference angle. How would I find my solution? I've got like two kinds of solution. Okay, let's write the first one. Okay? It's not going to be 72,5 because here cos is positive and it should be negative. So how would I go, let's put it this way. 72.5 is here. My cos is negative. Which quadrant will my solutions live in? Which quadrant?
3 or 2.
3 or 2, right? Cos is negative here. So how do I go from here to there? How would I get my quadrant, the second quadrant answer?
Changing to 180 minus.
So to find the first quadrant, or find the first solution which live in the second quadrant, I'm going to do 180 minus 72.5, which is equal to 107.5. Just check me, please.
Yeah, sure.
Yes, sir.
Okay. Yeah? Okay. That's my first solution that lives in the second quadrant. We know that there is another solution. This next solution, like Simon said, is in the third quadrant. Cosine is also negative here. How would I go from here to there? What should I do? What should I do 72.5?
180 plus.
I need to add 180. To go from 72.5 to here, I need to add 180. See how important this reduction formulas. They're very, very important, that picture. Okay? And then we get 252.5, check me.
Yes, sir.
Okay. So in grade, we've done that, believe it or not. We've done that in grade 10, and that will be it. That will be our two solutions. Again, in grade 11, we realize actually there's infinite more solution. Okay? That was really the hard work. The hard work we did in grade 10. Now it's actually easy. Okay? So what will be my solution? My general solution? Let's start with this one. 107.5 plus K times 360. It's the same recipe. And then the or, I can say or, theta equal to 252.5 plus K 360. What am I missing?
Oh, you want
K is equal
K is equal to integer.
Okay? K belongs to Z. And that's it. That's it. Okay? I'll pause again. Hello, hello. Okay, to finish up the lesson, is this on? It is. One of the questions, question 7, a homework, I wrote, is 3 sine theta equal 2. Okay, just look here, Simon, please. Okay, this is a little bit different because in all my example, I had the cosine or the sine without nothing in front of it. Now I've got that 3. How do I get rid of it? Yeah.
So you take the 3 to the other side.
How? So what do I write? Sine theta equal 2 over 3. So you see, it's one extra step. It's not difficult. You'll manage it, and then you carry on by yourself. Bye bye. Bye bye. Bye bye.